The project we were doing, we named as the cost of college education. The purpose of doing this project is all my students should gain a hands-on experience on dealing with data, developing the model, and analyze the model and apply it in the real-life situation. Good morning, class.
Good morning.
Very good. Awesome. How many more years will be here in this high school?
3.
Very good. You are in 9th grade now, so you should be here for 3 more years. How many of you will be going to college after high school? I think most of you. That is awesome. Is the college education is free? No. So, did you talk to your parents about, how do you pay for your college education?
Yes.
Very good. And we had a similar discussion before, and I asked you to talk to your parents about the positive and the negative sides of having student loan. Did anyone talk to your parents? Oh, that's great. Very good. Okay, Joshua, do you want to share?
My sister said that if the student loan helps you pay off the amount right then and there, but later in life, the interest rates combined on with the student loan and make it hard to pay off.
Very good. The other side of this is, I asked you, some of you talk to your parents or someone work for the financial institution or go to the local bank to find out the interest rate they offer for the investments. Did anyone do that? Oh, we have 1, 2, very good. 3, awesome. Xavier, do you want to share the class?
My mother and I were discussing the investment rates and federal student loan rates. She told me that the investment rates ranges from 2% to 4%, and the student federal loan rates ranges from 4% to 6%.
4 to 6%. So when you borrow the money, you have to pay 4 to 6% of the interest must be paid when you pay off. That is awesome. Great. Okay. So now here we have, we want you to get the real experience of predicting the future cost of college education, number 1. Number 2, you want to know how saving money can help you in future. So these are the 2 areas we are going to focus here. So we have, in this project, we have 2 characters here. Most of you know that. May I know the two main characters here in this task, in this project? Yes, ma'am.
Her grandmother Helen and her granddaughter Jessica.
Very good. What is the role of grandmother Helen? What she did for her granddaughter?
When her granddaughter was born, she put money into the bank.
Do you know how much money she gave? Maybe Jessica, she's a lucky person. If we have grandma like this, we could be millionaires by this time. Very good. Okay. So why grandma gave $50,000? What purpose, she gave? Because she had some extra money she wanted just to give to someone, or why she gave that $50,000 to Jessica? What for?
She gave her granddaughter $50,000 because when her son was in college, he took out student loans so he could pay for his education. But now that he's older, he's struggling to pay it back, and it's really become a burden to him.
Very good. I think most of you experience this. I think most of you talk to your parents. They hope they say the same thing. Am I right? Because when you go for a loan, that's good because someone is giving the money maybe to do your education. But when you pay back, it's a regular payment. You have to pay till the last payment, so you can't make any quick decision in between. That's a great thing, class. Okay, our next job is, so what we do now, how many of you are familiar with the College Board website? The College Board? Okay, very good. If you go to this website, you will see the data, the average cost of the college education, private school, public school, 2-year college, 4-year college. You will get this data here. So what you need to do, go to this website, and based on this project, what we are focusing 1 or 2 elements. In this case, we assume that Jessica is going to a private school. It's a 4-year school, and she is using the boarding and lodging facility. Okay, just to log in the system and go to the College Board website and collect the data. So we are collecting the data for the average cost of college education from 2006 through 2013. Based on this project, Jessica is planning to go for a private school. It's a 4-year college, and she is going to stay on campus. She will be going for the boarding and lodging. So please make sure log in and get the data, and please write those values on your sheet. So first of all, they should know the purpose of doing this project. So why should I do this project, by spending a week time? So that's the reason I said, okay, let you talk to your parents and get some basic information so that they can be ready, or they can set the goal for, to achieve something at the end of a week. So once they discussed with the parents, they came to know, yes, it's good that student loans are good for education, but, future they need to pay back. So why can't they know in advance how much they cost when they go to a real college, and why can't, now they have 3 to 4 years time, so they have enough time to make, necessary plans. Maybe they can look for some kind of scholarship or sponsorships. Class, if you have the data, so now you go to the Microsoft Excel, what is the first thing we do? We need to display the data. How are you going to display the data? In a table. I'm sorry? In a table form, then what? Scatter plot, very good. So, please go to Microsoft Excel and show this data as a scatter plot. Yeah. So what are the two variables here now?
The year and the average cost.
Very good. Which one of these two is an independent variable?
The year.
The years, the time, very good. Why that is an independent variable?
Because it won't change.
It won't change?
It'll keep going each year.
Very good. And which one of these two is a dependent variable?
The cost.
The average cost, very good. Why that is a dependent variable?
Because it's based off of the year.
Because it depends on the year. When the year changes, the cost is also changing. Very good. You got the data from 2006 to 2013? Okay. You got the data ready? So you made the scatter plot. So now you need to see the relation between the two variables, right? So did you see any relation between the two variables?
They're both increasing positively.
Positive correlation? Okay, how do you know it's a positive correlation?
Both the independent and dependent variables are increasing.
So both are increasing. So you said it's a positive correlation between the time and the average cost of education. That is great. So what is the next task?
But we find the best.
The line of the best fit.
Mm-hmm.
Okay, how do you find the line of the best fit?
When we click the dot here,
Okay,
We add a trend line.
we add a trend line.
okay.
Last two.
So we will find the average trend line, which would be 0.9624.
Very good.
All right.
Did you find the correlation coefficient from there?
Will we square root the answer
Very
because it's r squared?
Okay.
All right.
Do you mind, you can take your calculator, find how much is the square root of the value you see on the screen.
It would equal 0.98%.
Is it a good number? What do you want to say, based on this number, 0.98?
It's near perfect, almost a strong
100%,
correlation.
because
Almost.
it's a strong positive correlation between the two variables.
Mm-hmm.
That is excellent.
Some of the more uncommon strategies are questioning and encouragement of interaction. Anytime a student asks a question, he's, from my experience, never quick to give a direct answer. He'll always pose a question of, well, what do you think? And he'll get students to expound upon, I guess, prior knowledge that they might have. Maybe the first thought that comes to mind that enables them to interpret whatever scenario that might be present and to try to think it through.
Class, I hope you made the scatter plot. Did you? Yes, awesome. Did you find the line of the best fit? Yes. May you know the equation of the line? You got it. One of you please raise your hand and tell me the equation of, yes ma'am, what did you get?
Y equals 883.44x plus 34,944.
That is great. Did everybody get the same answer? Okay, you may round these answers to the nearest dollar. We don't want the answers in cents. If you want, you can have it. That's up to you. Now, do you mind tell the class what is that 883 stands for? One of you can tell the class what is that 883 stands for.
It stands for the predicted amount that she's going to have to pay on each year that she goes to college.
Okay, if 883 is the, do you want to give a different explanation for that? Okay, go ahead.
883 is the average increase per year.
That is awesome. Do you want to add something else?
I was gonna say it's the slope, how much it increases per year.
The rate of change. So that's the linear model, that's the linear function you learned in your 7th grade or 8th grade, fx equals ax plus b. What is that a stands for? The slope or the rate of change. Am I right? So in real life situation, we may not use the same terms here as she said. Do you mind, you can repeat one more time what you said about the 883?
883 is the average increase per year.
You get it? So she didn't use the word slope. She didn't say what? Rate of change. She didn't say rise over and gone. Okay, so she used the new term based on this data. That makes sense? There you go. What is the other number you said? 35,000?
34,944.
Do you mind, you can tell the class what is that number stands for?
The predicted cost for her first year of college.
Which year?
Her first year, 2006 to 2024 through 2025.
Class, do you agree with that? The 34,000 is the cost in 2014? No. Then what is that value? Yes, sir.
34,944 is the cost of, it's the predicted cost of the college in the year 2006, 2007.
2006 and 2007. Does it make sense? You get it? There you go. How do you connect with this function fx equals ax plus b? What is that b stands for? Say loud. The y-intercept. Who can explain what is that y-intercept stands for? Or how do you get, when you draw the graph?
Oh, it's where the point crosses the zero on the on the x line.
Very good. When the value of x is 0, that's the initial value you say, am I right? Because in your data, that's the very first number you see on the top of the table, or a number like that. Okay, so that you learned this is the y-intercept in your 8th grade. You get it? But here we say it's completely new definition saying that, who said that? You said, okay, that is what? The value, the predicted cost for the year 2006 and 2007. Make sense? Your next task is use this model and please find what is the total cost for 4 years. Okay, you substitute the right values for t. Okay, find the cost for all 4 years and let me know the total cost for education. Class, please keep working. Okay, if you need my assistance to build the same model using the graphing calculator TI Inspire, so please come and stay here. The key idea is students should know how to collect the data. That is a sample. So now they know similar data they can collect for different purposes. It depends on what kind of research they do in future. So once they have the data, they should know how it looks, because the key idea is how do I connect the real world with mathematics and mathematics with the real world. So now they have the data, they got the data from the website. So how do I convert this into mathematically? So that's the reason I started with the scatter plot. Then from there I can take them to what kind of relationship between the number of years and the average cost per year. Then they will develop a mathematical model, different models, what they learned in the 9th grade, linear as well as the exponential model. Okay, what can I help you?
How do you make a scatter plot, please?
Very good. Did you enter the data in the calculator?
Yes, sir.
Very good. Okay. The first thing is to make a scatter plot. So what we do now? Go to the main menu. Then what? What is the third option there? Data. Very good. Then what is the very last option there?
Quick graph.
Very good. Okay, so this will give the scatter plot. When you do the purpose of giving the project-based learning like this will help us to see the strong as well as the weak areas of students. Students may be very strong in maybe calculation, but they may not be equally good in using the technology. You know, we will see their strengths as well as the weak areas through projects like this, because this is a stage-by-stage process. At every stage, you know, we have some rubrics, we have some checkpoints to see whether they met or not. If not, you know, we can differentiate based on their needs. Some students, they needed some reteaching the concepts, some they need one-to-one assistance in, you know, dealing with the technology. Class, we have two models on your hand now. Am I right? So what are the two models you have on your hand? A linear model and what? An exponential model. So our next job is to find out which one of these two is a better model. What can I do? What should we do? I'm sorry, I didn't hear you. Go ahead, say loud. Very good. Who can explain what is residual and why we need to find it and how that is important to make a choice? Megan.
Okay, well, you subtract the predicted value from the observed value, and then you'll get the residuals. And then when you add all the residuals up, if it's close to 0 and the graph doesn't have a pattern, then it's a good model to use.
Do you agree there? Very good. Your next job is, so you have two models on your hand, and you know how to find the residual analysis. Based on this, you talk to your partner now, okay, and choose which one do you think is a better model to predict the future cost, okay? If you think linear model is a better model, then you have to tell the class, why do you think so? Same way, if you think an exponential model is a better model, then you need to tell us the reason behind this. Does that make sense? Okay, we will give you maybe 2 minutes to discuss with your partner and choose one of the two models which you think is a better model. Okay?
Which model do you think is better?
The linear residual plot.
Yeah, we have the linear residual plot, and then we also have the exponential.
Which model you prefer is a better model?
The linear residual.
The linear model?
Yeah,
Okay.
the linear model, the sum of the residuals for the linear model is 15.
Okay.
In contrast, the sum of the residuals for the exponential model is 23.
Why do you give more importance for the linear model than the exponential model?
Because the sum of the residual is closest to 0.
In the linear model? Oh, great. Okay.
So the linear model is much more accurate than the exponential model.
Okay. What happens if it is, you know, if the time is more than 50 years, then what will happen? Which one will be a better model? Still linear is a better, or exponential is a better model?
It's hard to determine, but I think that the exponential model is probably going to be better as the number of years and the time builds up.
Okay, good. Okay. Okay, where are you now? In 9th grade standards, insisting them to learn about the linear as well as the exponential model. Now they should know the difference between these two models as well as the relation between these two models. So that's the reason I made them to develop or derive the two models. Then let them do more research or discussion about the two models and let them come up with their own understanding. So that's the best way I can see how much they understood. You know, what are the strong areas or what are the weak areas, so that I can modify my instruction, you know, future instructions based on their needs. Okay, class, now we need to know which one of these two is a better model. Okay, do you mind, you can share what your team came up, you know?
We believe that the linear model is the better model because the sum of the residuals is close to 0 and the sum of the predicted costs is $208,000, whereas the exponential is more.
More, so because the sum of, you know, the linear model gives the least amount, so you prefer the linear model. So we heard that linear model is a better model, okay? Do you think that the other model, the exponential, is also a better model? Oh, great, okay. Do you want to say us why it's a better model?
We believe that the exponential model is better because it shows a higher predicted cost, which will better prepare you because it's better to have more money left over than not enough.
Oh, that's a great explanation, okay? So we have two different teams, we have two different, you know, views on selecting a better model, okay? Great.
Today we worked on a presentation, and during that presentation,
there was a lot of work that had to be put into it so that it was accurately displayed. The other students and I worked for about a week on that project, and we were just graphing. We went to the College Board website and we got the data, and from there we were able to design all these other functions and equations, and we put it all together into one presentation which we displayed to you all today. And you know, I had some fun. I learned a lot about college education and tuition fees and some other concepts which I hadn't learned before. That project, I'm probably going to have to construct a similar one for my own when I'm planning for college.
Class, this is the time for project presentation. So let us hear from each team about their model and the challenges they gone through in the process of developing their model. Okay, we will hear from you. Yeah.
We are happy to present our project to you guys today. I'm Artia.
Hello, it's a pleasure to meet you all today. My name is Tijan. Our project is on the cost of a college education. Our subject here is Jessica. Jessica's grandmother, Helen, invested $50,000 on her first birthday. By the time Jessica was 17, that amount grew to about $100,000. The interest rate was 4.2%. We're going to show you all how that money grew.
We used the website College Board to find the cost for Jessica's 4-year nonprofit boarding and lodging school. We then used that data to create a scatter plot. Using our scatter plot, we found the correlation coefficient, which is 0.98%. That means that there's a strong positive correlation between the number of years and the average cost per year. We then created a linear regression model, which we used to find the cost for 4 years. We used the function 883, which is the average increase cost, plus 34,944, which is the average predicted cost.
We also used an exponential model to determine how much Jessica would be paying for in college. As you can see by this function, the exponential model, g of x equals 35,003 times 1.023593 is the function that we'll use to determine how much money that Jessica will be paying in college. It's the predicted cost in the year 2006, and this is the growth rate. Jessica's total cost, the total cost for Jessica's 4-year in college is going to be about $220,000. Unfortunately, Jessica's grandmother Helen does not have enough money to pay for Jessica's tuition. She needed to invest $51,791 more in order to pay for all of her college fees. As you can see by this model, as the number of years increases, the total cost rises. This is the regression line. As my partner just said, the correlation coefficient is 0.98. It's a strong positive correlation.
We then created 2 residual dual plots, the exponential and the linear residual dual plot. The sum of the residuals is significant, which means that it's close to 0.
We have 2 residual plots here. Well, the exponential residual plot, as my partner just said, is insignificant. There's no discrete pattern. Again, as the number of years increases, it's impossible to determine what the residual is. So that shows that this residual plot is very accurate. The sum of the residuals for the exponential residual plot is 15, which is very close to 0. In the linear residual plot, it was also, in the exponential residual plot, the sum was 23. In the linear residual plot, the sum was 15. So we chose the linear residual plot because it was closer to 0 than the exponential residual plot. But both are good models.
What one thing you learned from this project?
This project helped me because I know the rate that I need, and I know how much that I need to save for college, and it also helped me with making financial decisions later on in life.
This project will definitely help me in the future when I'm planning for college. It gave me a better understanding of how student loans and college fees work, and it will help me when I'm applying for a specific college.
Most of all is that he just sets a high expectation for his students. He always asks the critical thinking type questions in his classroom, so that atmosphere is you can just feel that when you go in his classroom. And he really steps back, and he's more of a facilitator than a traditional teacher in the classroom. So the students really feel like they have a stake and have a part of his classroom.
This is what I was doing for the last 3-4 years, and I see the difference in the student engagement level as well as their learning style, and always teach less and make the students to do, learn more. Project-based learning is the best way to develop that kind of habit among the students, because we are producing this 21st century workforce, so they should have all the necessary skills such as collaboration, communication, critical thinking, and creativity. So the question is, as we teachers, how do we, incorporate all this in one lesson, one assessment? Project-based learning is the only option for that.